Welcome to This Explainer. Now, I know I'm usually your host, but today I need you to think of me as your chief architect. We are stepping right into the blueprint room. This isn't just a regular classroom. It's a highly specialized construction firm where we don't just solve math problems. No, we engineer them. Today, we're taking on what is arguably one of the absolute most critical structural foundations in the entire Cambridge Mathematics AS and A-Level 9709 syllabus. I'm talking about topic 6.4, the Central Limit Theorem, the CLT. Now, to really master this, we're going to learn from the mistakes of two junior builders on our site. I want you to picture them. First, there's Builder 1. Let's call him Alex. Alex is the kind of guy who just loves to stack up massive, heavy bricks of raw mathematical facts and formulas. He just piles them on without ever checking if his steel frame can actually support that kind of weight. Then, on the other hand, we have Builder 2. Let's call her Sam. Sam is the exact opposite. Sam wants to put up these shiny glass panels and intricate decorative features, beautiful, elaborate, flowing sentences, but she tries to do this before even cementing the foundational columns. She completely misses the core command words. Listen to me. Neither of these approaches will survive a Cambridge examiner's site inspection. If your building falls apart under stress testing, you lose the marks. It's that simple. So, gear up, strap that hard hat on, and let's get to work on constructing an unshakable mathematical high-rise.
Take a look at this quote. This acts as our ultimate architectural mandate. It comes directly from the core principles of the Cambridge Assessment Framework itself. It says, top-performing students exhibit connected conceptual understanding transferable to unfamiliar contexts. So what does this actually mean for you down on the ground level? Well, it means that passing your exam isn't just about memorizing heavy bricks of formulas. Let's be real. If you just memorize that z equals sample mean minus the population mean, all divided by the population standard deviation over the square root of n, you just have a brick. And a brick, my friends, is not a building. You have to build a conceptual steel frame that adapts to literally any structural exam challenge they throw at you. The Central Limit Theorem is exactly that. It's this magical structural reinforcement that allows us to assume a normal distribution for our sample mean, provided our sample size is large enough, which, as we know, is usually greater than 30. And get this, that's regardless of how the original population is shaped. It bridges the gap between the totally unknown and the perfectly normal. When examiners throw an unfamiliar context at you, say, a super skewed distribution of wait times at a specialized medical clinic, your conceptual understanding of the CLT is the steel frame that keeps your analytical argument from collapsing.
All right, here is our masterclass blueprint for today's build. First, laying the CLT foundation. Second, constructing the procedural structural framework. Third, critical analysis and stress testing. And finally, reviewing the top examiner's structural failures. We're going to stick to this precise plan to conquer the CLT modules without any structural collapse. Phase 1. Laying the CLT foundation. In any construction project, if the foundation is off by even a single millimeter, the penthouse is going to sway in the wind. The exact same is true for Cambridge mathematics. Without logical, heavily structured reasoning, any mathematical argument you try to construct will instantly sink into the mud. We have to adhere to strict building regulations, which are represented by these 3 load-bearing columns you see here: analytical depth over breadth, systematic analysis, and evidence-based reasoning. Let's do a quick thought experiment. Imagine a high-tariff question asks you to evaluate whether the central limit theorem is necessary to find the probability that the sample mean is less than a certain value. Pay attention to the command word there. The command word is evaluate. If Sam, our junior builder, who absolutely loves shiny glass, writes a beautifully descriptive paragraph that just defines the central limit theorem, what happens? The structure instantly collapses. Boom. To evaluate properly, you must look at the population distribution. If the population is already normal, well, the CLT is not necessary. But if the population is non-normal or unknown and the sample size is over 30, then you state that the CLT is strictly necessary. That right there, that is systematic analysis and evidence-based reasoning in action. You aren't just describing a concept, you are assessing the structural necessity of the theorem based on the raw data they gave you. Phase 2, the procedural structural framework. Okay, let's walk through this 5-step sequential blueprint. This forms a load-bearing, totally unshakable mathematical response block for complex exam questions. Step 1, deconstruct the question. Step 2, extract relevant data. Step 3, select analytical framework. Step 4, execute with clear notation. Step 5, present with correct terminology. To show you just how absolutely critical this is, let's observe an ironwork peer debate. I'm looking over at the drafting board right now,
and Alex and Sam are staring at a heavy 6-mark CLT question involving a sample of 50 commuters. Alex immediately grabs his calculator. Let's just slam the calculation down, he argues. Find the mean, plug it into the z-score formula, write down 0.8413, bam, done. But Sam shakes her head. No way, Alex. We need to write an essay about how the Central Limit Theorem allows us to assume normality because 50 is greater than 30, and then we have to describe the shape of the bell curve. Listen to me, both of their frameworks are fundamentally flawed. They're going to fail the audit. Alex is completely ignoring step 5 and step 4. If he just writes a raw number on the page, the examiner has no idea what he actually calculated. There's no notation. And Sam, she's ignoring step 2 and step 4. She isn't extracting the data to actually execute the math. They need a system that perfectly balances the math and the rationale.
This brings us to the essential mental scaffolding you need to ensure you never, ever skip a foundational step. It's a punchy memory hack. DESEP. Deconstruct, extract, select, execute, present. Let's apply it to that commuter question. First, deconstruct. We identify the command word, which is usually find or calculate in this context. Second, extract. We pull out n equals 50 and we clearly identify the population mean and standard deviation from the messy text. Third, select. This is crucial. Because the population distribution is unknown and n is greater than 30, we actively select the Central Limit Theorem framework. We state that. Fourth, execute. We write the notation out clearly, showing the variance divided by n, and calculate the z-score precisely. And finally, present. We write the final probability using correct statistical terminology, explicitly linking it back to the commuters. If you follow DESEP, your structure will never fail a site inspection. Ever.
Phase 3. Critical analysis and stress testing. Before we secure this high-scoring paragraph framework, I need to call a site inspection. Make sure your own construction line is permanently reinforced. Hit that subscribe button for Ace the Exams at the handle @AceTheExams right now. And turn on all notifications to receive our weekly structural grade upgrades. Whether you're building an IGCSE foundation or setting up a massive A-level skyscraper, this channel is your primary grid. All right, back to the build. Our junior builders, Alex and Sam, have hit an unexpected structural roadblock mid-paragraph. They're trying to compare a small sample of 10 to a large sample of 100. Alex writes, 10 is bigger than 10, so it's better. Sam writes, a sample size of 100 is quite large, whereas the sample of 10 is somewhat small, making the larger one vastly superior. Do you see the problem? Both of these are structurally unsound. A generic answer is just a weak, hollow analytical beam. They are completely failing to link their evidence to the main thesis column. To fix this, we use the Peel methodology: point, evidence, explanation, link. We use this to rewrite their text out loud, line by line, to create a perfectly engineered load-bearing response block. Watch this. Point: the reliability of the normal approximation depends critically on the sample size. Evidence: sample A has n equals 10, while sample B has n equals 100. Explanation: because sample A is less than 30, we cannot rely on the CLT. However, sample B's size of 100 exceeds the threshold, meaning the distribution of sample means will be approximately normal. Link. Therefore, the probability calculation for sample B is structurally sound. Now that is how you construct a strong comparative analysis that actually holds weight. Which brings us to a really critical question for you. What causes a high-level math response to collapse under examiner scrutiny? Let's do an interactive viewer rebar stress test. I'm addressing you directly for a live site safety audit. Look at the factory scenario on the screen. Imagine a 60-second visual countdown timer ticking away. Here's the scenario. A factory produces steel rods with a mean of 50 centimeters and a standard deviation of 2 centimeters. They take a sample of 40 rods and they want the probability that the sample mean is exactly 50 centimeters. So what is the core metric you need to extract here? Did you catch the structural flaw? If you just started doing complex z-score calculations for an exact value on a continuous normal distribution, well, I hate to break it to you, but your building just collapsed. The probability of an exact single-point value in a continuous probability distribution is always 0. This is the ultimate stress test. You have to identify the mathematical reality of the site before you blindly start pouring concrete calculations. Phase 4. Top Examiner Structural Failures. I'm pulling up the official principal examiner reports right now, and I want you to notice the 3 massive structural failures that cause past student structures to cave in year after year for topic 6.4. First up, forgetting proper format. Students lose incredibly easy marks because they just don't format their normal distribution correctly. When you apply the CLT, you absolutely must show that the variance of the sample mean is the population variance divided by n.
If you just write down the population variance in your brackets without dividing by your sample size, your format is completely broken. The math won't hold. Second, ignoring presentation checks. This means leaving messy working, failing to round to 3 significant figures as strictly required by Cambridge, or inappropriately applying continuity corrections when you shouldn't. If your presentation isn't precise, the site inspector fails the site, period. Third, generic answers lacking specific context. And honestly, this one is the most dangerous of all.
We have an official examiner alert. The report says, the classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario. Failing to anchor your mathematical concepts to the specific scenario is a guaranteed collapse of your marks. Let me give you an example. Let's say the question asks you to explain why the CLT was used in estimating the mean weight of 60 apples. If you just write, the CLT is used because n is greater than 30, so the sample mean is normally distributed, you will lose the context mark. There's no question about it. That is a generic, prefabricated wall that doesn't fit the custom building you're supposed to be working on. You must write. Because the sample size of 60 apples is greater than 30, the Central Limit Theorem allows us to assume that the distribution of the mean weight of the apples is approximately normal. Do you see the difference? You literally must use the words apples and weight. You have to integrate the raw materials of that specific site into your framework.
So, I leave you with this. Will your CLT foundation withstand the ultimate examiner stress test? You now have all the tools in your belt. You understand that you can't just be an Alex dumping raw calculations on the page without formatting, nor can you be a Sam writing eloquent but mathematically hollow paragraphs. You need the structural integrity of both. You have the DESEP memory hack to perfectly sequence your construction. Deconstruct, extract, select, execute, present. You have the peel method to rivet your comparative analysis together so it doesn't snap. And you know exactly how to avoid the fatal flaws of poor formatting, messy presentation, and contextless answers. Your next step as a master architect is to take this blueprint, open up a Cambridge past paper right now, and apply the DESEP framework to some practice questions. Stress test your own work before the examiner gets the chance to do it for you. Thank you so much for joining me in the Blueprint Room today. Keep building those unshakable foundations, and I'll see you on the next site.